All right, all right. Look at that. Ooh, echo, echo. There we go. Is the echo gone? Yes, it is. Hey. All right, hi, I'm John Park, and welcome to John Park's Workshop. Thank you, good people, for stopping by today. I want to say hi to everyone in the chat over on Discord and in YouTube. Let me pop up my YouTube chat. So we're off to a good start, right? Running a couple seconds late, but I've got audio working and video working. Hello, Mr. Certainly. Hey, Dastels. Hey, Yannick. Hey, Brentar. How's everyone? All right, let's see. Let me grab a YouTube window here. I was down at... there's a convention called VidCon that happens down in Anaheim, and there's a sub-convention or conference called EduCon for people who are teaching stuff on YouTube, or educators, or makers, science people, all kinds of cool people. That was a lot of fun, and it was nice meeting up with other people who are doing this kind of stuff. And enough stalling. I think I've got my YouTube. I saw people were talking about iced coffee, and I had one, and I think I finished it. Here's some water. I'm thirsty for iced coffee. All right. Hey, look, there's my YouTube. Let me pause that and pop open the chat. Pop, 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 pop out. There we are. All right. And we have the live chat. Excellent. Hello from Hamburg, Marcus Harms. Welcome. Imagination to form. The owl going to be like Clash of the Titans owl? That would be amazing. Maybe your version will. Mine might be a little friendlier. Mine's going to be based on Minerva. Does everyone know Minerva? Minerva is our Crickit playground character. You know, we have this series of characters, Adabot and Who else do we have? We have a 555 timer, right? What's his name? We have Cappy, the capacitor. We have a whole cast of characters, and one of them is Minerva. She's an owl. We're going to do, yeah, Mr. Certainly, it was a cool con. Met some good people, met some people who are makers, and help organize some of the maker YouTube education people stuff. So there's, hey, yeah, right there. There's our good friend. Let me pop open my Discord chat right there. You can see that's Minerva. Thank you, Brent. Minerva's adorable. Minerva's got attitude. Oh, named after Hans is the 555 timer. Named after the chip designer. I didn't know that. That's awesome. All right, so let's see. What do we got going on today? First of all, let me turn the music back up for a second. You probably hear that. Can you hear me too? I don't know if you can hear both. Let me throw on headphones for a second. Let's see. Can you hear me? And, oh, let me turn that down. Yeah? There we go. That's my level. Pretty good? I think my level's okay. Sound a little noisy now. So, a lot of you know that I like playing around with different kinds of synthesizers. Some free, some cheap, some expensive, some handmade. The thing I'm playing from here today is a Nintendo DS cartridge called Korg DS10 synthesizer. I've had this for 10 years or more, I think, and rarely played with it, but I pulled it out the other day, and it's super fun. It's a 2-voice mono synth, and it's got, let's see if I can point that at the screen and get the glare out of the way. Let's see, so you've got a keyboard, you've got a chaos pad, you've got a step sequencer, and then you can swap out here where you can start playing around with like the patch of your synth. So there's some of the couple of oscillators, VCA amplifier. You can see the filter. I've got animation on the filter sweep there. Pretty cool. And you can even go into a little section where you patch stuff a little bit. You can have a low frequency oscillator that changes stuff. I was complaining to my friend Todd earlier that this thing sounds just as good as hundreds and hundreds of dollars of synth gear that I have plugged together. Ah, Moore's Law. Darn you. So anyway, that's what that is. That's what was playing there today. And then what else? I think let's move on to our coupon of the day. Coupon code for the day is iCups. iCups. That'll mean more in a minute when we do our project, but iCups is the coupon code that will get you 10% off in the store. At Adafruit.com. If you head there, throw a pile of great stuff into your cart that you want to use, components to build things. Anything except for gift certificates, subscriptions, and software. But everything else you throw in your cart, if you use that coupon code, you will get 10% off. Yeah, Mr. Certainly says, woo, Korg. So I think this is based, this Korg synthesizer cartridge, which you can get for $9 used, I think. If you have any DS, DSi, DS Lite, 3DS, 2DS, any of the XLs, I'm sure you can play this cartridge. And there's an updated version that has like 8-voice polysynth or something crazy like that. But for 10 bucks, it's fun to play around with. And I think it's based on a Korg synthesizer called the MS-10. So they were clever there and called it a DS-10 because it runs on the Nintendo DS. You won't find that in our store, but you will find lots and lots of other great stuff. How's that segue? 10% off with the coupon code iCups. Cups. I'm providing my own echo here today. I think I had some echo running on the, or chorus. I had some chorus on this tiny little mixer running on that DS cartridge, but otherwise everything was coming from the cartridge. So, hey, how about this? How about we do a product of the week? Mr. Certainly, I love Electroplankton for the DS. I got that when it came out, and I don't think they made that many of them at first, and it like shot up in value. It was like $100 for a cartridge. Now I think it's like settled and you can just get them. But I love Electroplankton. I know some people who've got multiple DSs with multiple copies of Electroplankton running on there. Did you know Electroplankton was created by the same guy who created the sort of the precursor to the Monome, and I forget what the instrument's called, but it's like a 64-button grid that has multiple layers of brightness depending on the layers of the sounds and effects. I forget the guy's name, but check it out. If you just look up electroplankton on Wikipedia, you'll see info about that device as well. Pretty brilliant, fun, cool stuff. Not eye cops, no, but eye cups. Like these kind of cups. We're going to be using these cups today. All right, well, hey, why don't we move on to product of the week. So the product of the week this week is the Crickit for Feather. So this is called the Crickit Featherwing. So we've been using, as you know, the Crickit, which we can place a Circuit Playground Express on, but we have another Crickit here, which is out and available, and this is called the Crickit Featherwing, or Crickit Feather. And you can see here I've got a Feather M0 Express plugged into it right now, but it'll accept all of the feathers. And the really exciting bit is that you can, yes, can you believe that? Crickets have feathers now. You thought they flew with wings. I'm sure there were weird dinosaur-like crickets with feathers at one point. That's why I'm highly suspicious of birds. But one of the really exciting things about this Crickit that is for feather is that you can plug other feather wings on top of it. So I'm just mocking this up right here right now, but you can see I've got one of our little joypad feather wings that has a little 2-axis thumbstick and 4 buttons on it. And I've also got the OLED feather wing, which is a display, nice little display feather wing. Now, if you plug in a feather doubler, which is what I've got these on the back, and have the proper headers, which I don't right now, but you can imagine, I'm just going to mock that up by plugging it in with some of those nylon screws. Now you've got a Crickit robotics platform possibly that's got input. Let's say you wanted to program it to run a little pattern, kind of like a logo turtle robot or Big Track. Anyone remember Big Track? It's been reissued, so I'm sure people do. But it was a little tank toy that you could program straight ahead. You could say go 10 forward, turn right 45 degrees, go 10 forward, turn right 90 degrees, back up, and so on. Even had a little trailer that it could carry, and it could make pew 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 sounds. So I imagine you could build something like that using Crickit feather wings and the other feather wings on top to program it. Could be a kind of cool project right there. I've got a solenoid plugged into it right now. I haven't programmed it to do anything. I didn't have time. I wanted to, but I didn't have time to program this guy yet. But it programs in Circuit Python, and eventually we'll probably have it so you can use MakeCode on this as well, using the maker.makecode.com. But and Arduino as well. That should be coming or out. I don't know the status of that library. But anyway, super cool. That's our product of the week. It is $29, I believe. Someone can correct me if I'm wrong. That's the PID. The product ID is 3343 right there. If you go to adafruit.com/product/3343, check it out. And if you already have feathers and feather wings, it's a pretty complete, I don't know about complete, it's a very wide-ranging ecosystem at this point with lots and lots of things you can add on to it. If you wanted to add on MP3 playback, if you wanted to add on lots of NeoPixels as a display, if you wanted to add relays on top of it, all those feather wings that can go on top of this and run alongside the Crickit make for a really amazing ecosystem of plugging stuff together, plugging modules together, which you can then program to do some pretty fun and exciting stuff. One thing I was thinking about doing with it is thinking about the solenoids is we could plug in 5 solenoids on these, no, 4 rather, 4 solenoids on these using the drive section of the Crickit. So you could do a pretty cool little physical tapping drum sequencer type of thing, which would be fun. Something slightly to the side of robotics. You can definitely do robotics with this, but there's a whole lot of other things that aren't typically what you'd think of as robotics, that maybe don't have wheels or treads or legs or arms, but are powering little motors and solenoids and devices. So I'm excited about that. So that's the product of the week, the Featherwing Crickit. And it is, as Brent posted Oh, we have a Learn Guide up for that, so if you check on the Discord, we have a Learn Guide introducing Crickit, and it talks about all Crickit variations. So it's $29.95 in the Adafruit store, but don't forget, 10% off if you use iCups. All right. Now, moving right along, check this out. We have, dun dun dun, MakeCode Minute. Yeah, so thank you to Noe Ruiz of Ruiz Brothers fame for putting together that really lovely motion graphic for MakeCode. So the MakeCode, hey look, that's it right there. I'm inside of MakeCode. And now I gotta find where that is because that's a window. There we go. So I've got my little green screen background to chroma key that. And so what I wanna, I'm distracted because Imagination Forbes said, birds are biding their time to change back into dinosaurs and eat us. I knew it. All right, so MakeCode Minute today. What I want to talk about is functions. So far, a lot of the stuff we've done on MakeCode Minute is plugging together blocks in a series or sometimes in a loop. But when you get into a more complicated program, sometimes you want a whole little collection of blocks to be something that you can call by name and reference that collection of blocks without repeating it all over the place. So a way to do that is with something called a function. So if you look here in the left side of MakeCode, when I open up this advanced section, I have a category called functions. And in functions, I can make a function and then I can call functions. So these are two that I made earlier. So here's how you would make one. So let's make one that's called, how about noise function. So now I have a new function here called noise function. And noise function, I'm going to make some bleeping, blooping noises. What I want to use this for is, let's say I switch the built-in switch left or right on the Circuit Playground Express, and I want, when I go to one side, it to demo some noises for me. When I flip to the other side, I want it to demo some lights for me. So a way to do that is to create a couple of functions. So here I have noise function, and earlier I made a function called light show. So in my light show and in my noise function, I can have a series of blocks, and then when I either press a button or touch the tap sensor or move the accelerometer, or in our case, switch the switch, we can then have MakeCode run everything that lives off to the side over in one of these functions. So let's build our noise function right now, and then we'll take a look at the light function. So in music, we can bring in some sounds. Let's say play a sound. We'll pick the jump up sound. And then we'll grab some play tones and some rests. So these are pauses and beeps on the speaker. I'm going to duplicate these a few times so that I can have tones play and pauses. So here in middle C, here in the playtone, I click it was set at middle C, but that pops up this little piano interface, so I can choose a different tone here and how long it's going to play for. Let's say I want it for a quarter note. And I'll duplicate that and change the note, duplicate it again, and change the note. So now what's going to happen is when this function gets called, it's going to play this prepared sound called jump up, then it's going to play these different beats. And if I want maybe this whole thing to happen 3 times, rather than duplicating this whole thing, I can put it inside of a loop. So I'm going to pick this repeat loop and stick the whole thing inside of there. Let's make it run, let's say, 2 times. So now you can see I have this thing called noise function. I can change this name to noise show. Does it let me change it here? I think it does. Yeah. And now in my inputs, I can choose what happens when I move the switch. So when I move the switch to the left, let me bring this up here, and I'll move that out of my face. That's right on me. Hello. When I move the switch to the left, what I want it to do is, I'm going to grab from the function, call the function noise show. So now this sort of simplifies and neatens my code visually. It means that I can move this off to the side and kind of stop thinking about it. And now as I deal with the interactivity, what's the user going to do with the Circuit Playground Express, I just have this one little thing to call, and it goes and runs a whole bunch of other code, which is a sort of a nice, neat way to work. And now I'll duplicate this and say what happens when I move the switch to the right. We're going to call the light show. Okay, so I had some of these prepared before, and they're grayed out now because I've duplicated them, so let's blow these away. Delete. Delete. I had made a sound show before, but we'll get rid of that because I've now made that noise show. Goodbye. Okay, so I don't have anything happening in the forever loop. And when it starts up, I have the pixels going to sort of a light purple. So here's the flow of what happens. We have the Circuit Playground Express will start up. It'll set the pixels to this lavender color. And then it's just sitting around and waiting for me to switch to the left or the right. So I'm going to go ahead and download this. I've saved it. I've given it a name. So it's called the Functions Show. And let me plug in. So here's Circuit Playground Express. I'm going to plug that into USB. And I saw that Noe and Pedro were mentioning yesterday on their show on 3D Hangouts that they, I think in the beta version, can now save directly from from MakeCode to the Circuit Playground Express without saving it first to the hard drive and dragging it. I haven't tried that yet. That sounds awesome. So what I'm going to do, you won't see it here because I'm not sharing that part of the screen, but I've just hit download. I'm going to save file. It's going to save that to my downloads, and then when I press the, let me close this so you can see me again. Hello. Get some things out of my way. There we go. There I am. I'm going to press the center button. Whoops, I'm going to double click that. I say I'm going to double click, I'm going to single click it, sorry, single click it. It's now in bootloader mode, so it's waiting for me to drag that file on. That trips me up because on Circuit Playground, Circuit Python, we double click, here we single click. But I guess that's because we're not going to bootloader mode in the other, that's to restart it. Okay, so now let me make a new, you don't see this, but I'm opening up a window for my downloads folder, and I'm going to drag this UF2 file over to this cplay boot. You'll see it restart. So right now it is waiting for me to flip the switch. So I'm going to switch here. You should hear this. So here it is in light show mode, and now it just played the sound. Oh, it didn't play those beeps. What happened? Did I do something silly? Let's look at our code. Jump up half a beat and then play these tones. I don't know why it's not playing those tones. This is live. This is not pre-cooked. So what did I do funny? I'm resting. Let's rest for a full beat. Yeah, I should play this twice when I move left. Noise show, noise show. That all looks good. You know what? I'll also test it in the simulator up here. So when I click on the slide switch that's in the little simulator, it will either show the light show or play the sounds. So there's the light show, and I actually have to turn up my volume. I might echo here for a second, but hold on. Yeah, okay, that works. Oh, let me turn down my sound so I don't echo for you. So let's see. Why didn't it work on here? You tell me. It doesn't like doing that. It's beeping, but it's not playing the full thing. I don't know what happened. Let's yank out the repeat. So we'll try simplifying this down to just play the sound jump up for me. How about? So download that. I'm going to initialize the board into bootloader mode. Yes, definitely upload the changes. Thank you, Nis. Good call. All right, so drag that onto cplay boot. Where are you? There you are. Okay. So light show, and then flip the switch. All right, play the song. I'm going to leave it at that. I don't know why it didn't play the tones, but I don't want to take more time on this. If you have a problem with that, let me know. That should work, and my other example was basically doing the same thing, so I don't know what I've messed up there. But that is the power of functions. So you can build really large collections of blocks and then call them in multiple places and call them easily rather than having your inputs filled up. You can imagine if what we did was load all those blocks, and let's say there were a lot of them, into the move switch left. If we start having loops and conditions and things changing, you start to have just a few very, very huge blocks. Functions allow you to compartmentalize what you're doing in your code really neatly. So that is functions, and that is our MakeCode minute. And whoops, I'm not coming up, I'm right here. Hey, so that brings us to what? So tools and techniques today. I've got a couple things I want to show, actually. Let's head over to the workbench. So I'm going to switch cams over to there, and let me unplug that. And we'll go to that overhead view. So I have one tip here which is actually based on a vintage find. So I've mentioned I like to go to thrift shops and estate sales and things. So for $5.99 at the thrift store, I got this Dexter mat cutter. So this is for cutting mats, and it's got a beautiful graphic design logo. I haven't looked at when this was probably manufactured yet, but let's see if there's a copyright on here. None that I see, but the graphics make it look like it's from the 60s maybe. And I'll switch cameras so you can see that full screen. Hello, little camera. There we go. So that is the Dexter mat cutter manual with a professional bevel edge. So this is essentially a razor blade, a little special cutting knife. It might even have a special name, I forget, because this company mentioned they have some cool names for their blades. But we've got this mat cutting blade, I'll call it, which goes into this little adjustable for angle piece here, this little handle. So what you would do presumably is, if I'm going to put this at a 45-degree angle, and I'll check the depth of it to be enough to cut through a piece of corrugated cardboard here, but not too much further, something like that. I can then tighten that in place, and then you can, I'll do this properly in a second, but you can imagine if I push this through and have a nice straight edge, I'll get a 45-degree bevel on two pieces of cardboard, which I can then use as a matted frame, picture frame mat. Okay, that's kind of interesting, but much more interesting is the fact that we can now join things that have been cut at a 45-degree angle and make really nice boxes. So let's go to this view here and zoom in a bit. And I'm going to adjust this camera because it's a little dark looking. Let's go that away. That's a little better. So came with a little pack of 6 blades. And what I'll do is move some of these cups out of the way. We'll need those for the project in a minute. Just take a cutting mat, and let me cut off a small, just because I have a small mat here, I'm going to cut off a small slice of the cardboard to work with. So let's just eyeball that and that there. Oh, didn't make it through. Oh, and while I'm over here, let me pop up the Discord and the YouTube so you're not yelling at me that my audio is gone. Y'all there? Hello? Oh, let me open up the YouTube. Sorry, Matt, you're getting cut today. There we are. Hello. Someone has a question in YouTube chat. Robert, Eddie, can this work within Ubuntu 18.04? I have not tested that, but the MakeCode runs entirely in the browser. There is a downloadable version for Windows, but I've been running it on OS X primarily, or Mac OS, inside of the Firefox and Chrome, and once or twice in Safari. So I think there's a decent chance it'll run in Ubuntu, Robert. If anyone has tried that or knows, please let us know in the chat over in YouTube or Discord. So let's move that cardboard excess. Okay, so now what I can do is get a straight edge. I'm just going to take a speed square. And I'm just going to eyeball that alignment like so. That looks good. So now when I take the little mat cutter, I think it's a little deep as it is, but we'll see if that works. I'm just going to run it through. Oh, I made a mistake. Let's neaten that up. Maybe it wasn't as... Yeah, I made a little wiggle in there. You know what? In fact, I want to do it this way because you'll be able to see it better. So let me cut that off as well. All right, so this is a very short bevel we're doing, but the fluting is running this way. You can see it there. So I think it's kind of cool when you can see this bevel along the fluting. All right, let me try to get this dug down in there nicely. Okay, so now there we go. You can see here, if I hold that up, and hopefully you can see, I've got two really nice 45-degree angle bevels, which will now join up really nicely along here. There's some logo stuff on there you're seeing, so it looks a little weird. But boy, that's a perfect 45-degree set of edges, which join together a really nice 90. So you could, I'll just hot glue this here, so you can put some white glue or hot glue. I still haven't really tried the contact cement, or I've tried it once or twice, but haven't been using it. But however you want to adhere those, you can now... I don't know what a new mat cutter costs. It might be prohibitively expensive because it's a sort of specialized piece of gear, but for $6 at the thrift store, I was excited to find that. And there you go. You get a really nice, clean edge there. I've seen people make this sort of thing using X-Acto blades and small 3D printed gizmos to do a similar sort of thing. So I know it exists for people who do a lot of model making and architects. Having a convenient little way to do these kinds of cuts is helpful. I don't think I would have gone out and done that myself, but the fact that I found this at the thrift store, yay, and score. Let's switch back over to this view here so you can see it a little better. So there's my nice little 90-degree join using the mat cutter. So that's the first tool and trick and tip of the day. I'm just going to retract the blade on this and put it away. So yeah, I am set now if I need to do a larger scale production of cardboard work. And then the next tip and trick I've got is going to lead us into the project. So I'll go back to main cam here for a second and we'll get that guy for the overhead. So the trick here is one that our own Mr. Lady Ada, Phil Tyrone, showed me. And it's a very cool way to do eyeballs. If you saw the puppet based on the black hole robot named Bob, I think, or Rob, or Vincent. There's like a couple different robots in that one. But PT and Lady Ada did a Crickit video about a month or more ago, a couple months ago, and he had this really nice technique of these eyeballs looking back and forth. So he showed me, we got on a web chat, and he showed me how this works. So I'm going to show you a version of it just using a couple of clear cups. Unfortunately, these have a slight facet to them, which I didn't realize, which will make it a little less easy to see. But I'm going to get some clear cups and put this in the guide for this project. And I'm going to use some of these little eyeball stickers that I have. Let's get these nice big ones, actually. And you could do this with marker or paint. I'm going to do it with stickers. So let's put a, we'll do it this way, actually. So I'm going to put some eyes on my cup, like so. And for demonstration purposes, I'm just going to set it inside of this clear cup. And now you can see if we leave the clear cup, the outer cup rather, alone, that would be the head of our character, Oh man, there we go. Sorry about these reflections. But as we move that inner cup, we get eyeballs looking around. Now, what we're going to end up doing is motorizing this with a servo. But let me take a moment just with some paper to show you what the effect is when we have a opaque cup. So I'm just going to cut off a little section here. And you can just do this with some Scotch tape. So this is kind of a cool demo you can do if you're teaching a workshop to someone, to a class or something like that. So now you imagine here's our outer cup that's opaque. I can, let me grab a pencil. This pen bleeds all over the place. I'm going to make some makeshift eyeballs on there and just cut those out. Sort of roundy, square eye sockets. And unlike our single eyeball from last week using a gimbal mechanism, this is very efficient, right? That used a couple of servos just for the one eye. You might need to use 4 servos to do that technique for 2 eyes, or you get involved with some complicated linkages. This is a single servo that moves both eyes, which is generally what eyes do, unless you need to do like a cross-eyed gag. But if you want a character that's going to be able to look around, like this adorable little fella here, you can just move that inner cup around and you get adorable adorableness. Hello. Looks kind of like a, I don't know, like a shy guy or something like that. I imagine if you were going to get crazy with this, you could also do up and down movements. If you were moving a servo on a servo with a linkage, you could possibly do up, down, left, right, get the full 2-axis rather motion. Okay, but that is the basic technique that we're going to use to create our project today. So that is why our coupon code of the day is cup eyes, because we're making cup eyes. So let's now, oh boy, I've had that tools and techniques thing up there the whole time. Let me go turn that off. And switch it for project build, because that's what's coming next. So for the project, what we're going to do today is actually not just eyeballs. We're doing this owl. We're going to do Minerva, as I mentioned. Where'd our Minerva go? Let me switch back into Discord and scroll up. So there's our Minerva. Get her out of the way of the project build. And we're going to do both. What this is called in animatronics often is a function for whatever reason. So not exactly the same as the function in MakeCode, but it's the word of the day somehow, function. So we're going to do 2 functions for our robot or for our animatronic. Our owl will be able to both move eyes, left and right, and flap wings. So we're again going to use 2 servos to do these 2 functions, separate functions in this case. And we're also going to have a sound function. We're going to use a speaker and wave files. And this is one of the super cool things about Crickit, which I haven't used any platform like it, in the sense that it makes it pretty easy to do audio while doing other things. So the fact that I can play back wave files and flap wings and move eyes is, it maybe doesn't sound like it should be hard, but it is normally. It is, for whatever reason, a lot of platforms, excuse me, will play a sound, finish the sound, do something else. And it's a lot of programming trickery to do anything at the same time. Crickit actually makes it pretty straightforward. So why don't we build the robot, and I'll give you a sneak peek of what it's going to look like here. And then we will program it. So here is, I'm not going to show you what it does in its final form yet, but here is the goal. So we're going to do a Minerva based on a couple of coffee cups. These little paper, what do they call them? I got these at the party store, and I think they call these paper hot beverage cups or something like that. But you could use pretty much any kind of cups that you've got. Solo cups, you could get clear cups and paint them, use paper. I made my life a little easier by finding cups that were the colors that I wanted to use. So let's head over here, and I'll show you how I built the different sections of these, and then how they can go together to form the wholes. I'll put away this speed square. And I also will, if we have time, show you a couple techniques for building this tree and a couple little characters that we have, these little owl characters with googly eyes. And these will all be in the guide. So if we don't get to that, we're going to build that. We're going to build onto that. If you didn't notice, Minerva has these gear cog or gear teeth emblems inside of her design. So I'm mimicking that a little bit in the tree here, and we're going to do a bit more with that. So let's switch now to, oh wow, why is that camera zoomed weird like that? Is it just in that view? Hey, weird. Something happened over on, what am I doing on that one? Oh, I didn't switch yet, that's why. Huh. There we are. Whoa, now we've switched. Definitively. Okay, so now I'm going to do, from a little overhead view, let me show you first the way I'm doing the eyes. So I had, after I talked to PT about this, I started playing around with this idea, and you can see here, here was when I just tried it with some Sharpie. For some reason, my instinct was to put these cups upside down. That actually makes life harder for you, because driving that from a servo from below, unless you got a hat to hide a servo up in the top, doesn't work as well. So I was talking to Lady Ada, and she said, here, check this out. This is, if you do these right side up, you can actually place your servo motor through the base of one cup and attach it to the base of the other cup, and then you've got a real easy way to move them. So that's what we're going to do. So first thing I'll do is take what's going to be the outer cup, and on this one I'm going to grab a compass, and I've already made some marks on here just so I know where I'm doing these, but I'm going to go ahead and mark out where I'm going to cut, a little bigger than that, for the eyes. And you want to line these up probably, unless your character has unevenly spaced eyes, because they look a little nutty. So let me cut those out, and a way that I've found is a little easier is if you can get a sacrificial cup inside so that you have something to cut against. Be careful not to cut your fingers. And you can take as much time as you want to get a nice round eye socket here, or you can rush it like I am, because I'm on this show right now doing this, and they might be a little uneven. But I'm just going to go over these a couple times to get through. Sharp blade helps. You can see this one's starting to come up, but is not quite through. And you can also, if you come up with a pattern that you want to make a template out of, you can also, if you don't have a compass to use, you can cut out a circle from a piece of paper using a coin or some other object and transfer that circle to both spots. There we go, we're almost through here. And these are, as you can tell, their color it's a laminate, so there's a white paper and then a purple paint paper on this one. And you can clean up the white edges that show through if you want with marker later. Minerva has black eyelashes, so I'm going to go in and clean those up with black marker. But in the meantime, let's go ahead and cut out our second eye. And it's definitely a weird surface to cut because it's curved in a couple of dimensions. Also, my pencil line is a little faint, so hard to see. Now, there's probably some cool stuff you could do if you used a continuous rotation servo where you could switch out different eye shapes by rotating between a couple of angles in the front and then maybe switching all the way to the back side of your eye template. You could probably fit 3 different, maybe even 4 different pupil shapes, which could be kind of fun. Okay, so there is my eye sockets. I'll go ahead and, where's my, I only lose black Sharpies. Every other Sharpie just stays put, but black ones, aha, there you are. Oh, let's pop up another view there. There we go. How we doing on time? All right, got 12 minutes-ish. So I'm just going to go in with the marker and, whoops, that's not too bad though. We're going to do eyelashes. I'm just going to color in that white edge, and then I'll just put a couple of lines for some eyelashes in for now. But if you look at the design, actually, Minerva has lashes all the way around and then some longer ones in the upper corners. Oops. Again, take your time with this so you don't make a mess. There we go. So there are the sockets. What we're going to do now is the inner cup, I'm going to just put some white paper around it. Let me get one that's not cut up like that one. I'll save that for later. So here's a clean inner cup. So I'm going to take some white paper to give us a foundation for the eyes. And I'm going to cut this a bit thinner. We're going to cut the cup sizes down a bit just to match the proportions of the character a little better. It doesn't have as tall of a head as all that. But I think that will, yeah, that'll cover it. So I'm going to just use some tape, some Scotch tape, and place that on like so. You'll see it'll curve around a little bit because of the conical shape, but that's okay. Shouldn't be noticeable. You do want to make sure that the tape lays flat and the paper lays flat so that we don't catch these edges in the seam. There's always a seam on the inside of these cups, so I'll run a strip of tape across that seam there and there. Okay, so now that'll turn nicely in there, and we just want to add pupils. So you could definitely draw them on if you want. I'm going to use some of these cute eye stickers that I've got. I like these. These have little Pac-Man notches in them. Like that. Oh my God, it's cute. So let's get another one. And it's adorable. For the ones that I did before, I painted or used colored marker to put some nice irises on. So you could do that. Let me grab a light colored marker. Here's a green one. I think her pupils are kind of blue, right? Yeah, they are blue. I don't think my blue is light enough, but oh well, we'll just faintly put in some irises. Again, you could take some care and some time. You could cut out a nice little disc of color to put under there. But that's what I'll be doing. All right, so next thing we'll do is we're going to cut these down to size. I had mentioned wanting the height to be a little less. And since I had looked to see if I could find some sort of like a bowl. By the way, it's hard to make a cut like that around these without accidentally finding that you're a half an inch off by the time you get around to the other side. So what I like to do is take a marker and place it on something tall enough to spin the cup. That's a little low. Let's find something a little shorter. You can stack some things too. I've got a chunk of aluminum there. That's good. Yeah. So I'm going to hold the marker in place and just spin the cup around so that we get a consistent line there. All right, so now I can cut on that line and not screw it all up as I come around to the other side. You could use scissors for this. In fact, I will. Like so. And it's a little easier, I think, if you just give yourself a few starting points so you're not bending things as much. You can even come in diagonally like using a bandsaw. Now I'm going to cover the front. You could fold these flaps over if you want to make the top of the head. I'm going to cover it with actually a piece of, you could use another cup. I'm going to use a piece of paper plate. And now what I want to do is place the inner cup inside of here and then measure where the line is, because they've got a bit of a base. It's not going to be the same height. So where's my inner cup? The inner cup's going there. There's my eyes, and I just need to mark a little bit lower. Grab this marker again. A little bit lower than here. Say about there, that'll be hidden. Since it's hidden, you can be a little sloppier with it, so I won't bother marking that. I'm just going to eyeball it so long as it's not so short that it comes down inside of the sockets. It doesn't matter. That's good. You don't want a lot of pieces to catch on, like I mentioned before, so just trim off any little flaps. Okay, so there's our inner eyes, and now they're hidden well enough inside of there. So now let's do the mechanism. So one thing I did, you can see on here, I might not have time for, is more decoration. So I cut a piece of paper plate and made this rounded bit. And I used some, ooh, those are nice scissors. Mr. Certainly posted in Discord some nice looking, they almost look like bandage cutting scissors. What are they? They're for cutting cardboard. There you go. Straight blade and X-Acto knife. Yeah, you know what, Mr. Certainly, I don't like to use scissors on cardboard because it does tend to dull it. Although, if I use any, it's these Engineer brand ones that have a slight serration to them, and that gets in there pretty nice, and I think the serration has not dulled from clogging with fibers. So you can see also I cut off some different color cup for a lightning bolt on the chest, wings, and a beak. We'll get to the wings, maybe not the beak and the lightning bolt. We'll see how much time we have. But those will be in the final project. So next thing I'm going to do is, for the mechanism, what I want to do here is just poke a hole in the center. You could measure this. I'm going to simply eyeball it. Actually, I'll tell you, here's a trick for if you don't really want to measure it, but you want to get it pretty close to center, is take your compass, which I have lost. Where'd my compass go? Here's my compass. You can kind of tell just with the compass when you've got it right. So I can set this to the edge and poke a hole, and that's going to be pretty close to center. And I'm poking that through both cups. I can see a little mark where I started it. And now I can make those a little bit bigger, because what we're going to do is fit the micro servo up into the bottom one, and then the shaft and a servo horn are going to be glued to the top one. So I want this hole to be where the center goes, and then I just need to cut away enough to fit the top of the servo housing into there. So I'm just going to take a pencil and mark off roughly that little circular bit there and cut that away. You can also, let's see, this is the outer part. Yes, yes, you want to double check that. You can also leave some little flaps to fold up in there, which might give you a nicer press fit. And it's a slightly oblong circle, but if I just poke that away there, now I'll test and see, does that servo fit up there? Yeah, pretty good. So that's up in there with the shaft at the center still. And then this is going to go on top with the servo horn. So the easy way I've found is, I'm going to pull these tabs away. I will place the servo arm onto the shaft of the servo and then place hot glue on top of the arm and then set this down on top of here. That gets you a centered fit. If you're a bit off, it'll probably still work, but you might hear the servo struggling a little bit. Now this you can maybe just set in here, or you could dab a little bit of glue on it. I'm going to do that just so it doesn't move around on us. I found if you leave some of these connections a little loose, you pick up some free head movement, which is nice, because we're going to attach the base of the microservo to the body. If there is some slack, then the head will wiggle a little bit before it kicks the eyes in gear, which is kind of cool. All right, so that will now take a microservo horn. These come with a bunch of these in the pack. So I'll take a nice big one here. I'm going to place it on top of there. It's actually a little easier to access through Minerva's eyeballs. And the only trick here is that we want it to be centered before we place the cup on top. So we need to have software to run on there. I will show you how to set this up properly in the guide, but what I have right now is my software is running on this Crickit here. So when I plug the servo in, I will be able to center this just by, it's the first thing that happens when it turns on. So I'm going to turn it on and off, and that means we'll find that 90-degree spot of the servo. So plug it in. If you watch my servo horn, okay, so that's 90. That's the middle position. So that means we'll be able to place the cup down on here and sort of have a assurance that it can find this spot and then it can deviate off of it a certain number of degrees in either direction. So we'll dab a little hot glue onto the arm here. You don't need too much. If you put a ton of hot glue, it just takes a lot longer to cure because it's cooling and it takes longer the more it is. All right, so I'm just going to tap that down onto there and let it cool. Don't be tempted to turn it on yet because you'll twist the servo off of the eyes probably. So we'll leave that there to cure for a second while we start the body. So for the body, what we'll do is we're going to cut out, essentially build a neck for ourselves. And what I chose is a smaller, this is like a 12 ounce versus a 16 ounce. I think I have those two sizes. Let's see. What are you? 354 milliliters, 12 ounces. Yeah, so these, oh, sorry, yeah, the purple ones are 12 ounces, and I've lost the packaging for the others, but they're probably like an 8-ounce one. That means that our neck fits inside this shoulder, if you want to call it that. So this I can make a little mark of how it's going to fit on top, and then we're also going to need space to put the servo for the wing flap. What I found is a decent method of transferring this position is to put a bunch of Sharpie marker on the corners. There's little screws in the corners of the servo, and then set it down and try to transfer that mark. Try to center it. This is a bit of guesswork here. And so now I got 4 marks. You can barely see them, but I got these little marks plus an extra blob. But that shows me where that servo should sit for this to be pretty close to center. It's not exact. And again, I'm going to cut it to the line so that it can be a little bit tight at first, and we can adjust as needed. And I'll just cut that all the way out. And now we're going to feed the cable from the micro servo in. And I'm pressing down from the top here so I don't separate anything. And okay, I can see I've cut it a little too small, so I can make it a little bigger now, just in the length. And I might just fold this down instead of cutting it away. Let's see. That's looking good. Okay, so now we have our micro servo popped through for just holding this in place, and I think that's cooled long enough that we can test it out. So again, this is jumping ahead. I've got software on here now, but we're gonna let me unscrew the speaker from here so we don't jump too far ahead. Unplug that. That we don't need. I need frequent cleanup stops during these projects. All right, I'm going to set that over there. What can you see? Okay, you can, it's not too much chaos, I hope. And if we give power to the Crickit board now, we should see the eyes. So what I've programmed them to do is this little look around, left, right, middle, and every 2 seconds it's repeating that. Okay, so that's the inner cup rotating based on that micro servo. So that's looking good. Now what we're going to do is add a wing flap. So these are a little crude, but I'm just going to cut them out and go with them. So here's another cup that I just cut open to get access to this material, and I'm going to cut out some wings with these 3 finger-like wings. I'll make this thumb or pinky a little smaller, and I'll give it some angle. Okay, so that'll be one wing. I'm going to trace that to make the other one, but a mirror image of it. So you could give these different designs if you want. It'd be kind of cute to have a fist, maybe, a closed feather look to it, but I'll just keep it simple and have symmetrical wings. Move that up in camera a little for you. And this material is really nice. It's maybe slightly waxed on the inside, not so much on the outside. Paper, like a chipboard or paper board. Okay, so that's good. Now that means we have, if I did this right, a couple of symmetrical wings. Yes, we do. And the way I decided to attach these is I'm going to put a little bit of a bend in, but not crease it too much at the shoulders. And then we're going to attach those to the cup here. And the way the function is going to work is we're going to have a servo on the back with yarn that's going to pull them back and then release. And so the untensioned position, I want these kind of forward, and then the tensioned position with the servo and the yarn, untensioned, and they'll flap at the same time. So you could cut some little slits in and attach these, or use tape. I'm just going to, again, use our good friend, hot glue. Again, just a couple little dabs is enough. And I'll get these a little forward of center. I made these kind of small, I'm realizing now for this one. I like my proportions on my original better, but maybe this is Minerva's cousin, who's got small arms, or wings. All right. Good, so let's let those also cure or cool. And now what I'm going to do for the servo is I'm going to take a full-size servo, one of these, and we're going to embed that maybe here. I'm trying to see if I did a, yeah, it doesn't matter too much up or down. I'm going to leave it pointing down. And again, I want to mark and cut that in so it just holds it in place. And you could double up the inner cups if you needed to as well. If you needed thicker material, that would work. Let's grab a Sharpie, is fine for this. And I just want to mark the corners so I can cut that out. Carefully not moving that too much. All right. The reason I just muted was to ask my son, who's home for summer break and playing loud video games inside. So I'm the mean dad who just asked that to be turned down. Mean dads. All right, so I'm just going to slice out that. And be careful when you're free-handing it with an X-Acto knife and these cups. So now we'll be able to set this servo in here, and that'll hold in place really well. I don't know if you need any adhesive or anything. It's just kind of stuck in there nicely and a little bit angled. Before I put that in, I'm just going to be careful of this other wire. I'm going to trim the base so it's a little shorter, so we don't need that much length at the bottom. And we will use some popsicles for legs and some pipe cleaner feet. And those are just going to be decorative. I don't think we'll make her stand on them. Okay, that's a little better proportion. So I'm going to drop that wire all the way out through the bottom. I'm going to place this through the bottom, and then we'll have some space for the wire to come up through once we put legs on it, or we can cut some out. So this one here, I'm going to do the same thing. I'm going to plug that in to center it to its 90-degree mark, and that'll allow us to place the yarn under tension to these wings. So turn that on. Okay, it just went to its center position, so I can unplug that. We'll take a servo horn. A longer one might be better. It'll give you a little more motion. This one's okay. And what I'm going to do is I'm just going to take my knife and bore out these little servo connector holes a little bit. It's a soft plastic, so it's fairly easy to... Here, I can switch cameras for you. Let's give that a focus. Oops. Try that again. Focus. Yeah, sort of. So I'm going to bore out these holes so they're big enough to feed some yarn through. They're pretty small. They wouldn't allow anything other than fishing line normally, or some very, very thin string or wire. So that's probably good. These don't need much strength, so it's okay if the walls get fairly thin. And now I'll take some short bit of yarn, like so, and I can lick that, gross I know, and try to feed that through there. Hopefully it doesn't unravel too much when you're doing it. And now let's go to the opposite side. And you can see what we're going to get is, as we turn 90 degrees from center, the right, or what will be the upper piece of yarn will pull one wing, and the lower piece will pull the other wing, and that'll make them flap at the same time. And these could be separate pieces, but it's kind of easier. You don't have as many knots to tie or anything if you just pull it through something like that. And now we'll place that onto our servo here. Zoom in a bit for this operation. So remember, we centered that, so that's where the wings are in their forward position. And then I'm just going to tack this on with a little bit of hot glue, our good friend hot glue. You could also loop these around or tie them. Whoops, there goes my microphone. And Seagrover has a good point. Her wings are normal size. It's her big head, because she's so smart, that gives her these proportions. I just watched the N is for Noise video when I was preparing for this. In fact, I got some audio clips from Colin to use from them, and I love Minerva. She's great. All right, so we'll get this one on here the same way. Just a little dab of hot glue will do it. And you just want to make sure this is under some tension as it goes on. Just a little bit. Hold that there as it cools a little bit. And so what we're going to end up doing in software, you saw it before, I'm going to have essentially a function or a procedure that pauses a couple seconds, and then it's going to play back a audio clip, a WAV file. And while the audio file is playing, it's going to run the servos left, right, to do some flapping and some eye moves. So the wave playback function actually is what's going to contain the instructions for the animations as well. All right, so let's go ahead and snip the excess wire, or yarn rather. Snip and snip. And I'm going to wait for that to cool just a little bit more before I use it, so I don't end up snapping those off of there, or pulling those off of there. But there is our beakless Minerva. In fact, while those cool, let's put a beak on there, because that looks weird. And how about, oh yeah, so I just freehanded a couple of hopefully close approximations of her lightning bolt there. So we'll cut those out. We can put that on her chest. Oh, come back here. What am I doing? Oh, I almost just cut the whole thing in half. That piece there. That there. There and there. Okay, and you could tape or glue that down. Just going to take a very small dab of glue and place that there. Cute! I like that lightning bolt. She shares that lightning bolt with Adabot, doesn't she? They have the same lightning bolt. And for a beak, I'm just gonna, let's see, did I want to do that? No, let me fix that. So I'm gonna actually cut out kind of a diamond shape and bend it so that I can tape down or glue down a flap. She looks weird without a beak. Maybe just like that. And we'll tack a glue. There she goes. All right, so I think this is probably cooled enough that we can put the wing flapping servo test. So I'm going to plug this into, actually servo port 2 is where I have instructed the servo for the wings. So I'll turn that on. Oh, okay, so what are we doing wrong? It is not pulling. I think I got to reverse that. Okay, so let's pause. Pause that there and rotate this. It also is a little loose, so I might have to tighten. Yeah, I got to tighten this yarn up. I'll just pull this through and see if I can loop it around another piece. Maybe that'll work. So let's watch this from the back side as I turn it back on. Yeah, that's better. Okay, so now you can see the wings doing their thing. So it's subtle. You could leave it this way, or you could increase the range. This is going about, what, 45 degrees? Yeah, so you could go full 90. You could also go full 180. And I got this idea from the Trash Panda that Dana Wall did. So there's a Learn Guide tutorial that shows the Trash Panda from the cardboard box from Amazon. All right, so now let's do the full thing. So what I'll do is I'll turn this off, and I'll plug in both servos, and I'm going to plug my speaker back in, so now you can hear the wave files that I have on here. So on the Crickit, we have this terminal block here that's connected to the built-on amplifier. There's an amplifier built onto the Circuit Playground Express itself. I believe that's the one we're using here. There's nothing different about it on a Crickit other than this connection. And someone correct me if I'm wrong, but I think that's the A0 pin audio out unadulterated. You call it as A0, which is the audio pin on the Circuit Playground Express. All right, and let's fire it up.
Let's try the walkie-talkies again. Lots of things can create electrical noise. I can't quite hear you, Adafruit.
Minerva.
Loud and clear.
That's right, Minerva is loud and clear. So this little speaker packs a wallop, makes quite a bit of sound. And then everything from here is really about decoration. So you can see on the one I did earlier, I've got some paper plate to give this rounded head shape. I made her cute little feather and her kind of gear motif that she has using some pipe cleaner. And in fact, let's dress up this one because it's a little further along. And I was going to take a couple of our popsicle sticks. Let's see, let me get some purple ones because she's got sort of purple and blue motif. And oh my gosh, we're 20 minutes long. Okay, we'll end it very soon. But here, let's take, we can in fact use one popsicle stick. I'm just going to cut it in half. Give that a little wiggle. And we can put on some little legs like that. Something like that. Oh, these are uneven. Let's make her legs even length. There we go. We could put them on the inside, or I don't know, I kind of like seeing them like that, so let's do that. And then what's she got for toes? I'm looking at that image that we had up earlier. She's got some little cute blue toes, so let's take these and let that cool a little bit. And then I'll take a pipe cleaner, one like this, and we can just fold up a couple of, cut this, it's thin enough to cut with scissors. I'm just going to cut a couple pieces of the pipe cleaner, and I'll just give them two little toes, like so's. And can you see that? Yeah. And glue that on there at an angle. That's good. And let's do the other one. They're cute little fuzzy feet for our friend Minerva. Oops, sorry, I need to move that up there so you can see. There we go. There's her adorable little fuzzy feets. And let me pull that camera back out. And then if we look back here, you can see I've taken some nice thick cardboard from a large box, and built a little tree from it. So you remember our little slotted tabs from a couple weeks ago. I'm using those to hold this in place, and oops, maybe go there with that one. So this will sit like this, and then I've got these little screws, SCRU screws from MakeCode, which make for some adjustable branches, and I'm using some little pipe cleaner feathers on here. And then these are these cute little, we got this idea from a book on cardboard, and I'll link to it in the guide. But these are paper towel or toilet paper roll owls that you can make, where just bending in the tops gives you this cute little top of the head and wing or an ear tips look with some googly eyes. So then I think everything from here is decoration. So I said I've got some paper plate gears on there, and I might use some of these other little plastic paddle wheel gears, and then we'll be able to have our Minerva with her tree. And I was realizing as I was putting this together, I must have been heavily influenced by, there was a show that played on like a New York public television channel when I was a kid called Magic Garden. So if people remember Magic Garden, it had like a laughing tree and laughing flowers or something, and I think there was an owl. Anyway, that suddenly jumped into my head as I was working on our little Minerva project. So that is our owl robot. I hope you've enjoyed it. So I'm just going to head over to the workstation and, whoops, there goes Minerva. Sorry, Minerva. And we could check out the chat, where I'll be hanging out for a little while after the show. So thank you everyone for stopping by. Thanks for the chat and the tips and ideas in there. I hope you'd enjoy the Owl Robot. Don't forget your coupon code is iCups, and that's going to get you 10% off in the Adafruit store on your whole cart other than software, gift certificates, and subscriptions. So go check out all the good stuff we have there, and stay tuned for the Learn Guide for our Minerva Owl Robot, coming soon to an Adafruit learning site near you. For Adafruit Industries, I'm John Park, and I will see you next week on John Park's Workshop. Thanks so much for tuning in.